What a beautiful.
No, that's what, it was so either.
What do you want? Yeah. Pretty. Look at the bigger. Oh,
You made this?
yeah. I do can
What's it for?
Physics 2 projects. One for honors. They make them. It's upside down.
Oh.
You don't have like a mirror. You don't turn it over so I can flip it around. Or that would do it. That's the. It's a word. What is the word? You can adjust it. You just gotta be careful.
Oh, it's using a lot.
Yeah. It's called a telescope version.
Like I can see one letter at a time. You visit the telescope. Oh, that was really fun.
Galileo.
We're probably feeling like Galileo.
You're not Galileo.
Hang on.
How's Galileo doing something? Depends on how much it's from.
Are you guys just doing?
Oh, I have this in my.
That please.
That is not what I meant. But yeah, I've been doing my services. Yeah. Well, that's actually I can do. Is it good? You can adjust it yourself. From just
You'll see it. It pushes in. Wait, I don't want to break it.
Yeah, don't push it too hard. I think you gotta do it.
Just push it in.
Hey, no one thinks that. We'll say what
You plus.
I
Well,
want to know. Unless you use. I'm ready for this. You're right.
we're going out faces it.
Wait, how many slurs?
Okay, that's what I was thinking. I can see.
If there's two people who speak to that.
Yes. Hey.
Okay, so any questions before we get started? So today will be the lecture. We're going to review the things that we're going to go through for the final, right? But before we go into that, I think I'll still spend a few actually a good amount of time to go through a few questions that's related to your midterm 3. I got asked this few questions several times last week. So I think it's actually good to discuss those things first. Okay. A few things I want to also point out first. So remember I said that there are 2 bonus points I can give for the students, right? So the second one will be due this Friday, and all of them will be updated on Friday as well. So you should be able to see that actually on Saturday with all these updates for the bonus point. And then for the partial credit for your midterm 3, which will be the very last one we're going to do, this thing will be due on Sunday. Okay, it's a little bit earlier because at the end of semester, just too many things we need to handle. So I don't know how time I have to actually look at everybody's response, right? So these things I will post it on Microsoft Teams sometime today. So you have all this information on Teams. Okay. And regarding to the preparation of the final, so I strongly encourage everybody to rewatch the review videos for midterm 1 and midterm 2 and midterm 3. Okay, so after you watch those things, make sure you actually know how to do every single questions in that set. Then go back and redo your midterm 1, 2, 3 questions. Okay, so by doing that, I think you will actually finish more than 100 questions already. Okay, so that will actually give you a good grasp of the contents they are going to face for the final. Again, before you take your final exam, okay, so make sure you actually do the practice final exam. Okay. So your midterm 1, 2, 3 also have to practice the exam for midterm 1, 2, 3, right? Those are the material as well. Okay. So I know everybody has many courses to handle at the end of the semester, right? So the time you have is limited. So those should be actually the things you spend your time on. Okay. And we have all these out throughout this week. Okay, so it's always from 11 to noon. Okay, so just drop by if you have any questions. Okay, and I hope like this will actually help you to prepare your final. Okay, and that's pretty much what I can say. Okay, good luck with your final.
Okay, any questions though? Okay, if not, then I want to go through these few questions. Oh, another thing I want to
ask you to do is that if you have questions that you like, we have start to review all the questions in the past that you don't really understand. Trying to post those questions, including the correct answers, on the Teams. Okay, so it's actually a team channel for the Q&A sections, right? You can post it over there. Yeah, if you show up multiple times, I will show you trying to pick those things and then explain those things in the in-person lecture as well. Okay.
All right, so this question says, an ideal gas expands at constant temperature. What is the sign? Okay, positive, negative, or zero of delta H, delta S, and delta G of the system.
Yeah. So this is actually a chapter 16 questions. And it's actually not very straightforward to the students because so far you only learn that delta H from the entropy calculation. If I give you entropy equation, you just know you need to calculate that from the bottom mass reactor, right? But here is actually the deeper questions. You want to know the sign of delta H, delta X, and delta G. Okay. All the information you got here is what? It's under constant temperature.
Okay, so the right out of the data that you have. Okay, and then the volume is increasing, right? Because it says expanding. Okay, and then you have ideal gas. Okay, so those are the data that you have.
Okay. I think the most the information that makes most sense to the student is that the word expanding, the volume is increasing. Okay, so from there you probably can actually infer the delta X.
How would you predict the sign of your delta S?
It's expanding, right? Or disorder, therefore your delta S will be positive, right? And I think that's actually the only one you can check something say from the things they have learned from this lecture, right?
So I guess this is actually where you should get started. Okay, therefore, you see this.
That's like the only options that says that delta S is positive, right? So, of course, that's actually not the best way to solve the problem, but once you can identify this keyword, at least you need to pick up the option that says your delta S is positive. Okay, but we want to know a little more about that. Okay, so if you look at that options, you see that it says delta H equals to 0 and delta G is negative.
right? So why that is actually the case? Okay, so I guess by now you should be very familiar with the delta G equals to delta H minus T delta S, right? So you also know your delta S is positive, which makes the second term, including the sign here, this whole thing will become negative, right? Because temperature is always positive value. Right now, you have your delta S is also positive. Therefore, negative T delta S will be a negative term. Okay. So now, if you actually know the sign of this, then you will have a chance to actually know the sign of your delta G. Okay. Simple case is that if your delta H, if your delta H is also negative, then you will know your delta G will also be negative, right? Because it's basically a sum of two negative terms. Okay. However, we don't really know the sign of delta H. Okay, so this actually things up here is actually beyond your knowledge domain. Okay, so I will actually explain what does that mean by delta H in the give you some physical pictures. Okay, so when scientists actually describe delta H, okay, there's actually another name that you should know called the internal energy. Okay, so in the past, scientists consider every single molecule it has its internal energy. Okay, so how does actually the molecule get the internal energy? It's actually from the environment. Okay, so we live in an environment that the temperature varies from, today's very cold, but 0 degrees typically to 30 degrees, 40 degrees, right? So convert it into Kelvin, that's 230 something to 300 something. Okay, okay. So what it means is actually, if we consider ourselves as a system, we're always going to get the energy from our surrounding. Okay, because surrounding is always has a lot of energy, a lot of heat. Okay, and those heat actually goes into your molecule. Okay, so from the answer you can see here, we say for the ideal gas under constant temperature, the delta H equals to 0, right? So that doesn't mean there's actually no heat flow in and out of your system. Okay, you need to actually pay attention to the delta. That delta is actually a change of the internal energy. Okay, so you still get the energy flow from your environment to you. Okay, but all those things, all the energy you get, you're going to use it to do the expansion. You're going to do that work. Okay, therefore the energy inside you, there's actually no change. Therefore, delta H is going to be equal to 0. Okay, so, and this is only true when you have ideal gas. Okay, so there's actually two terms that's actually not really fall within the domain that you should know right now. Okay, so one is constant temperature, one is ideal gas. Okay, because in thermodynamics, we actually define the delta H very specifically. It contains two terms. One is actually your internal energy. The other one is actually the work that your system can do. Okay, so if you have ideal gas, okay, when you do the expanding, okay, your pressure will decrease. Okay, everybody know ideal gas follows this PV equals to MRT, right? Under constant temperature, your P times V, it is a constant. Okay, when you do this expanding process, that means actually the pressure of the system is going to decrease. Okay, that means actually the
the overall change of the delta H, which is the sum of this internal energy and the work you can do, it will become a constant. Okay, so let's actually count the fundamental physical pictures about why the delta H is equal to 0. Okay, but most of the time that may be actually too much for the students, right? So what you need to remember is that if you have ideal gas under constant temperature, okay, the delta H for ideal gas will always be 0. Okay, so take home message. If your ideal gas constant T, delta H equals to 0. Okay, of course, this I guess they ask this question and especially design the multiple choice in a way that as long as you can actually recognize that your delta S is positive, then you will be able to select the correct answer already. Okay, but just in case they change the choices that you have here, okay, the thing you need to know is that under constant temperature for ideal gas, your delta H will equal to 0. Okay, and then if you plug those things into your delta G equals to delta H minus T delta S, then you'll realize your delta G will actually have the same sign as your minus T delta S, which will be a negative value. Okay, so that's actually how you solve this problem. Any questions?
Okay, so this is actually more conceptual chapter 16 questions. Okay. So this is actually a chapter 17 question. Okay, so in this question you say, for this specific chemical cells, okay, and give you the cell notation. Which of the following change with decrease the voltage of the cell? Okay, then it give you option 1, 2, and 3. Okay. Here you need to actually recognize that the Q, right? You want to know what changes will actually decrease the voltage of the cell. Here to actually know this is actually your E cell. Okay. And then in chapter 17, we define the E cell equals to E naught cell negative 0.25693 over N times ln(q). Okay, so this is actually how we define E cell in chapter 17. Okay, the reason I want to actually write out the Q is because it starts to actually provide you the information about like the concentration of species, right? It says copper. Originally you have 1 m, but now I change it to 0.001 m. I would like to change my voltage of cell, right? So let's actually how I know I introduce the equation that contains Q. And then the only equation you have your E cell and Q is this one, right? E cell equals your E naught cell minus 0.25693 over N times your L and Q. Okay. So this is actually the first thing that you need to know. Okay. All right. So in order to answer these things, you need to actually know how to define your Q. Right. So this is actually a time that you need to actually really know how to read your E cell notation. Okay. So the notation always follow this ABC structure, right? Start from the anode, go all the way to the cathode, right? And then from the anode, of course, is your LoRa, right? So your LoRa says that the reaction is actually aluminum solid become aluminum 3 plus. Your cathode, which is your G-Rock, will be copper 2 plus, becoming your copper solid. Okay, then you can actually quickly balance this one. Okay, therefore you know the overall should be 2 times your LoRa plus 3 times your G-Rock. Right, therefore you're going to have 2 Al solid plus 3 Cu2 plus 6 electrons. They give you 2 Al3 plus 6 electron plus 3 Cu solid. Okay, 6 electrons, 6 electrons going to cancel out, right? Therefore, you know, to define your Q, it was simply equals to Al3 plus square Cu2 plus Q. Okay, so you actually write your LoRa and G-Rock so you know how to actually define your Q. Okay, so now you want to know how this E cell going to change, right? And you compare that to your original condition, where the concentration is always 1 m, right? So your original will be E cell equals to E naught cell minus the N equals to 6, right? Because there's a 6 electron transfer between your LoRa to G-Rock. Okay. 0.25693 ln(q). What should you put? The Q here. The concentration of your aluminum is what? 1, right? Because that's the original, right? So it's actually 1 to the square, 1 to the cube. Okay. And then we know this will be just natural log 1, right? So your second term will disappear. This will be just your E naught cell, right? So that's a definition, right? When your concentration is at 1 m, your E cell will equal to E naught cell. Okay. So that's your original. Okay. Now you're going to change your aluminum, right? So let's say your Al3 plus now become 0.001 m. Okay. Therefore, your E cell is going to equals to your E naught cell minus 0.25693 6 ln Q. Your aluminum is actually your numerator, right? So this one will be 0.001 to the second power divided by 1 to the third power. Right? So that's actually the new E cell you're going to have. Okay. So once you actually write the things down, if I want to focus on this part, would this be a positive or negative number? Natural log 0.001 square. Would this be positive or negative? You can use your calculator, right? Is this positive or negative? Negative, right? So this is a negative number, right? Okay, so how do you actually know it is negative? Of course, you can use your calculator. The other way is actually, you should know natural log 1 is 0, right? So anything below than 1 will give you a negative number. Okay, so since your natural log Q term is negative, see this negative term? Negative, negative. This will become positive overall, right? Therefore, this thing will actually larger than your E naught cell. Okay? You don't even need to know the numbers, but just from the sign, you should know that you are going to get a bigger E cell. Okay, if you change that concentration. Okay? Therefore, you know if you change your aluminum 3 plus concentration from 1 m to lead concentration, you are going to have increase of the cell potential. Okay. If today is actually your Cu2 plus, that become 0.001 M. Then your E cell will equals to your E not cell minus 0.25693 over 6 ln 0.001 to the cube. Okay, so this one is actually for your small number in your denominator, right? Which will make your ln cube a really big number, a positive big number. Okay. Since this is positive, this is negative, therefore overall it is negative 10. Therefore, you're going to have E cell. It's going to be smaller than your E not cell. Okay. So, with that being said, we know it is actually on this one will give you a smaller E cell, right? So option 3 is actually something you must pick. Okay. Now we come back to this. Okay. Increase the surface area of aluminum electron. Okay, so this is a trap, right? So this is actually the things that professors trying to create to confuse students. Okay, so what is going to change when you actually increase the surface area? How will it change? Every time we talk about the surface area, you actually change your reaction rate. Okay, but it doesn't change anything else. Okay, so in chapter 17, you see the options that's quoted out, that will never be your answer. Okay, this is actually very similar to one of the things we mentioned in the past. Like what is going to change the chemical equilibrium, right? So back to that time, the trap is actually catalyst, right? Your catalyst only change the activation energy, change the reaction rate, but nothing else. Okay, so the same thing here. Okay, you see it says the surface area, again, it's just going to change your rate, but it's not going to change anything else. Okay, since here it's talking about the cell potential, so that cannot be your answer. Okay, so with that being said, then you should know, since here you're actually looking for the conditions that's going to decrease your E cell, then you should only choose the number 3. Okay. You need to actually pay attention to this word because I see 2 identical questions. The only difference is actually one wants to actually looking for increase, one is looking for decrease. Okay, so if it's increase, then the answer will be choice number 2. Okay, so it will be either depending on this. If it's decrease, then we know it's this guy, right? But if I change this word to increase, then the answer will be that guy. Okay. The underlying logic is actually the same. You need to do the same analysis I just did. Okay, is that clear? All right. This is actually probably one of the most confusing questions that I was asked yesterday and kind of get stuck for a while. So this question says, balance the following equation in basic solution using the lowest possible integers and give the coefficient of water, right? So our QD pad, coefficient of water, right? Data that we have is this. and then we are in basic solution, meaning you're missing H, you use H2O, missing O, use 2OH minus, right? All right, so those are the things that we know. Then we start to actually assign the oxidation number, okay? This one is actually the one that confuses so many students, okay? So because typically we always assign the H with positive 1, right? This is actually the exception, okay? So how do you know you should actually consider this one as exception, okay? The rule of thumb is that if you see a H forming a compound with a metal, okay, then the H is not the regular H. The H will call hydride. Therefore, it's going to have -1 charge. Okay, so this is the part that many students actually didn't get in the first place. Okay, but once you know that, since the overall charge is -1, right? Therefore, you know the aluminum is 3+. Okay, so let's actually first step. Then you go to this, right? This one go back to the normal. Okay, your H is +1, you have 2 of that. Your O is -2, which will make your C 0. Okay? This aluminum 3+, apparently is actually 3+. Okay? Then we go to this. +1, you have 3 of them. -2, +1, will make this one -2. Okay? So that's actually the first oxidation number assignment. Okay, this one is actually a little bit trickier, so you kind of need to actually first assign it properly. Okay? Then we need to actually start looking for our LoRa and Gira. Okay. Who is your LoRa? This is abnormal, right? It's -1, right? And we know eventually five-way bonds is going to give you +1. Okay. Therefore, ALH4 minus should be actually the things you put here. But what is going to turn into at this moment it's not very clear. Okay, so we'll get back to here soon, okay? But G-Rock is easy to assign, right? G-Rock is actually your H2CO becoming CH3OH. Okay, so I assume everybody has no problem assigning your G-Rock. Okay. So get back to our LoRa. So what does this do? Okay, so aluminum hydride is actually a strong reductant. Okay, and in a solution, okay, we have a basic solutions, right? That means actually it's going to interact with your basic aqueous solution. Okay. So what it really does is actually interacting with your water. Okay. So I feel this is actually another layer of like chemistry sense that you need to have, so you know how to write. Okay. But let's say you don't have that sense. Okay. Then when we come to this stage, then based on the things we told you, okay, it is you have basic solution. Okay, if you look at this equation, you're missing what? You're missing aluminum, you're missing hydrogen on the right, right? So you will actually first balance your aluminum is actually easy. you can just add in Al3 plus and aluminum is actually done, right? Now the remaining is actually your hydrogen, right? So you have 4 extra hydrogen on the left, okay? And then in the basic solution, we know we will use H2O to balance it, right? Since you have 4 H on the left, therefore you add in 2 equivalent of H2O, okay? So far so good. Okay, so once you add in H2O, the problem is actually you introduce oxygen here now, right? So you add in 2 extra oxygen on the right. Okay, everybody follow the things I just said? Okay, so this have 2 extra oxygen. Therefore, you put in 4 OH minus to the left. Okay. But once you do that, you introduce excess H again, right? Then to balance that, you need to add in 2 H2O so that everything will be balanced. Okay, now I need to iterate a little bit. Okay, so once you do that, then I can combine these 2 terms, right? So I combine these 2 terms, so I can change this one from 2 to 4. Okay, then your balance, your hydrogen and oxygen. Okay. Everybody fine with this? It's a little bit kind of like you need to go back and forth, but that's how you do it. Okay. So we're going to do the same thing for your G-Rock, right? First, it's actually balance the one they undergo your G-Rock, which is your carbon. You have 1 on the left, 1 on the right. So carbon is actually fine. Okay. Then you look at your O. Your O is fine too. Okay. Then you look at your H. You have 4 on the right. You only have 2 on the left. Right. Therefore, you're going to add in H2O to balance your H. But once you add in H2O, you add in another O on the left. Therefore, you want to add in 2 OH minus on the right. And after this, you also want to balance the excess H. Then you add in another H2O, which will make this one 2. Then everything will be balanced. Okay, so this balance is a little bit trickier because you need to go back and forth. Yeah, and this will be the case because you actually your O is balanced first already. Then you start with your H. Okay. Then you actually balance that with your H2O. And then you need to do one more step to further balance your O afterward. Okay. But let me actually how you balance the atom for your G-Rock. Okay. So after you balance all these atoms, the next thing is actually to balance the charge. Right, so this actually -1, -4, +3. They're going to add in 8 electrons to make it both -5 on both ends. Okay. This is neutral, 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 -2. Therefore, you add in 2 electrons for your G-Rock. Okay. So up to this point, you balance your LoRa and G-Rock, both the atoms, both the charge. Okay. Then before you add in together, since this is 8 electrons, right? To get the final balance equation, you need to do LoRa plus 4 times of your G-Rock. Okay, so if you do that, then you're going to have AlH4 minus plus 4OH minus plus 8 electrons plus 4H2CO plus 8 H2O. They will give you Al3 plus 4 H2O plus 8 electrons plus 4 CH3OH plus 8 OH minus. Okay. Then we start to cancel out things, right? 8 electrons cancels out. 4 OH minus, this one will become 4. 4 H2O, this one will become 4. And that's it, right? So your final balance equation will be AlH4 minus plus 4 H2CO plus 4 H2O becoming Al3 plus 4 CH3OH plus 4 OH minus. And we're looking for the coefficient in front of your H2O, then the answer will be 4. So this question, I have to say, is actually a more tricky question. Okay, because if you rely on first, for your lower internal is AlH4 minus is going to becoming Al3 plus H2O. Okay, so let's actually count the first step. That you have some sense. Okay. And then the balancing is also a little bit trickier because you have to go back and forth to balance your H2O and balance your OH minus, and then rebalance your H2O again. Okay, and this thing will be repeat in both your lower and G rock. Okay, which makes these things actually become a little too much for the student. Okay, but if you need to understand what I say, this is actually how you solve this. Okay. Yeah, so any questions? Okay, so if not, then I think there's actually one more questions here. Oh, this is actually not the one I want to say. No, that's fine. Okay. So I guess we're going to actually some one question similar to this one in the previous review too. Okay. So it says if the age of the Earth is 4.5 billion years and the half-life of potassium-40 is 1.26 billion years, what percentage of the Earth's original amount of K40 remains today? Okay. Keywords. Half-life, right? Half-life electric keywords tells you that it's a very standard things you want to do, right? So equation you're going to use is actually nature log AT over A0 equals to negative KT, and then K times your T half equal to 0.693. So these are the two equations that you must use for this purpose, right? So the problem is that how do you actually assign information from the question into the variable that you have in the equation? Okay, so first thing first, every time if they provide the half-life, okay, the things you do is actually calculate your K first. K will equals to 0.693 over your T half, which is 1.26. Calculator, please, because this I don't have the number here. So let me need billion years reciprocal. Okay, so let's see K. Okay. And then here I want to actually try to interpret this. Percentage of the Earth's original amount of K40 remains today. Okay. And then here's another information. 4.5 billion years. Okay, so how does this actually translate to the variables here? Okay, so you have ln AT over A0 equals to negative KT, right? At this moment, the K is actually already known. Okay, so what is this? 4.5 billion years. This will be actually the T that you're going to use, right? So this will be negative 5.5 times 10 to the negative 1 times T is 4.5 billion years. Okay. So on the left, you have natural log AT over A0, right? Okay. What's this? What is this? What is the variable? It asks you what's the percentage of Earth's original amount of K40 remains. AT, how many was it AT? How many was it A0? The answer is this. Do you see that? Can you actually translate into this? It's AT over A0. Because asked about the, it says the percentage, right? Percentage is actually the key words. Then you translate is actually the ratio of the 2 times 100. Okay? I hope you can see this because I feel like students have difficulty to see these things. So if you can recognize lab, you can actually solve this, right? Because you just take the exponential on both terms, then you get your AT over A0. Multiply 100 and give you the percentage. Okay, so that's actually how you solve a question like this. Okay. Yeah, I missed one question here. I guess there will be it then. So that it will be actually there will be the question I want to go through that's related to your midterm 3. Okay. So what we're going to do is that we're going to use the remaining half hour to go through the key equations that you will need to actually revisit, get yourself familiar with. Okay. But I think it's actually good to summarize the key equations here. So you can always have a reference point, can come back to these videos and then make sure you have those things memorized. Okay. So first thing first, that's the very beginning, okay, that we have. This is the beginning of the semester where we start to introduce you the concept of mole. Okay. And then we start to teach you about all these different concentration terms. Okay. Molarity, molality, mole fraction, mass percent, and the molality. Okay. So you should still memorize all the definitions. Okay. This is actually for the chapter 12, right? And then in that chapter 12, there's actually one very important concept that we have learned. Okay, for this solution, right? We learned about the entropy of the solution is composed of three terms. Delta H solute, delta H solvent, and delta H mixing, right? And one of the questions you are going to be asked, and that's a little bit confusing to the student, is that if today I say your delta S is negative, okay, then these are the things that you should know. It's an exothermic reaction. Temperature is going to increase, okay? So the lattice energy is actually smaller than your hydration energy, okay? So lattice energy was delta H of your solute, right? This one is typically positive. Okay, positive means actually to give energy to pulling apart. Okay, delta H mixing is actually something that interaction between your solute and solvent, and typically that is actually a negative term. Okay, this one will actually associate with your hydration energy. And then this one will related to your lattice energy. Okay. So if your delta H is negative, that means actually delta H mixing is actually a dominant term. Okay. So your lattice energy will be smaller than your hydration energy. Okay. And if your delta H is positive, then means your lattice energy is actually larger than your hydration energy. Okay. So this actually is something that I think if you know it, you know it. Okay. If you don't, then when we go back, it's going to be very confusing. Okay. Next big topic in chapter 12 is that we start to talk about the solubility. Okay. So basic idea is light is of light, right? If you have hydrophilic molecule want to dissolve in hydrophilic solvent. Okay. So how do we determine one thing is actually hydrophilic or hydrophobic? And then the way we teach you is that if you do see this OH, NH, they are hydrophilic, they like water. Okay. But if all you have is CH or halides, they are hydrophobic. Okay. Next one will be how the temperature and pressure is going to change your solubility. Okay. So it depending on what kind of solute that you have. If your solute is a solid, typically higher temperature, you dissolve more, right? So I think the basic idea, the way to actually comprehend this is just think about some examples, right? So the sugar water or salt water, okay, if you increase temperature, you know you can dissolve more, right? So if you have solid, if you increase the temperature, solubility will increase, okay? But if your solute is gas, right? So think about your Coke, okay? If you raise the temperature, all the gas will bubble out, okay? Then the solubility of your gas will decrease. Okay? So if you have low things, then I think it's easy to understand this, okay? The other one is the pressure, right? The pressure only going to affect your gas solubility. Okay, and then from there, we actually teach you the Henry's law. Okay, the solubility, the concentration of your gas inside your solution will be proportional to the external pressure that you have. Okay, so there's actually a Henry's law constant. Okay, to form that relationship. Okay. The next thing is actually the collective property, right? So we have 4 collective property. One very important thing is actually to know how to determine the Van Hoff coefficient I. Okay, so it is actually a non-electrolyte, meaning that it doesn't dissociate into charged particles, then I equals to 1. Okay, so if you have sodium chloride, once it dissolves, it produces 1 sodium plus 1 CO minus, then the I equals to 2, right? But if say you have NgCl2, okay, so once you dissociate, you have Ng plus 2 CO minus, then your I will equal to 3, right? 1 plus 2 equal to 3. Okay, so you need to know how to estimate I, okay? And then the next thing you should actually pay attention to is how the vapor pressure, osmotic pressure, within a freezing point and boiling point change as a function of I, right? So we know that osmotic pressure and then the boiling point will increase. We have larger I, assuming the concentration is the same, okay? Then your vapor pressure and freezing point will decrease with a larger I. So the trend you need to actually be very familiar with. Okay. So let's actually all the things we covered for chapter 12. Okay. After that, then we'll start to talk about the reaction rate. Okay. So for the reaction rate, you want to know the differential rate law and the integrated rate law. Right. So for the it's actually the how we define the rate. Okay, so to get the overall reaction rate, you also need to actually do the delta reactant delta T and then divided by lag coefficient. Okay, and then if the actual reactant is the negative sign, then the rate is always positive. Okay. The reaction rate is actually an exponent n, right? So n is actually the orders of less certain species. Okay, but you should also know that to calculate the overall orders of the reaction should be the sum of the order n of different species. Okay. Integrated rate law, we have 3 orders, right? Zeroth order, first order, and second order. And you need to actually memorize these equations. And after that, we start to talk about the activation energy, okay? And then how the reaction rate change with the temperature. These are the equations that you need to actually memorize. Okay. That's actually one very important concept for chapter 13 is that the elementary steps, right? So how to actually determine the final rate law from the elementary step. The basic idea is actually to identify what's your rate limiting step, what's actually a slow step, starting from there, right? And then do all the possible substitutions so that when you write out your rate law, everything is actually expressed in terms of your reactant. Okay, so those are the things that we cover for chapter 11. Okay. Then we come to the chapter 12, where we start to introduce you the chemical quotient Q and the equivalent constant K, right? So in that chapter, one big things that we talk about is how do you derive the new equilibrium constant when you do some operation on your equations, right? So if you flip the equations, then you put -1 in the exponent, right? If you multiply a coefficient, then you multiply those coefficients on the exponent as well. Okay, so those are kind of the basic rules that you need to actually understand. Okay. And then the other thing I think I did not write here, but I guess it's good to know. So if your Q is larger than K, that means you have too much product. Okay, so the reaction will move to the reactant side. Okay. If your Q is smaller than K, then you know the reaction will move to the product side. Okay. And in late chapter, then we start to tell you all these Lechatore principle, right? How the things is going to change with the concentration, pressure, temperatures. Okay. I just mentioned this, right? The catalyst. Okay. Catalyst is not going to change the reaction direction. All it changes that the rate, okay, how fast is going to be able to reach your equilibrium. Okay, so those are the key concepts for your midterm one. Okay, looking back this equations. Okay, I want you to ask yourself, which is actually the part you will most likely be asked in your final. Okay, so if you look at this, which chapter gives you the most equation? The first one, right? Chapter 12, right? Okay, so among chapter 12, which one will be the one you got asked the most? I will bet the collective property. Right, because if you know how to do collective property, then it's actually to know how to calculate your concentration, and to know how to count the I. Right. So that single question where you cover a lot of different concepts. So that could be something that the professor would like to actually use, right? Because I only have 31 questions for you. I'll actually test how much you understand. Okay? You can see how the problem is designed. That's the things I wanted to see too. Okay, because this is just one course, right? Think about if you apply the same knowledge to other things you want to learn, you'll start to see why they ask these specific questions. Okay, and that's important. Okay, you want to see the insight. Okay, so let's actually, we quickly went through the key things for 3 chapters in maybe 5-10 minutes, right? So what should you do after this is go back to that midterm 1 review video, okay? And then don't just jump in and do every single questions. I want to actually look at the questions, read the questions, and then ask yourself, do I have a good idea how I can proceed? Okay, you have been practicing your skill for the whole semester now, right? You should feel like you learn a lot about how to operate your calculator this semester, right? So that's actually one thing you have been practicing, right? The other thing is actually you should learn a lot about when I see the questions. I will actually naturally try to connect to the necessary concept, the necessary equation. Right? That's the things that you have been trained for the whole semester. Okay? And that's the things you should do for what we do in the future. Okay, every time you see something, you know, okay, this must be related to this. Okay, you may not know exactly what you're going to use immediately, but you have a good idea about where to head to. Okay, so once you have that, then you can start to think along that direction deeper. Then you actually memorize the equation that you can use. Okay, and that's actually very important. Okay, especially for the test for your CHEM2, right? CHEM2 is actually a lot of calculations, right? Time is very limited. Right? You're actually not just challenging yourself to the knowledge, but how fast you can give out the correct answer, right? And that's a part that requires a significant amount of practice. Okay, so I respect people actually putting efforts very much because I hope you also see that it is not easy. It takes time. Okay, so
I always appreciate people really spend their time and effort to make something look nice. Okay, that's actually valuable. Okay, so eventually everybody will need to be a person that you can produce those things. Okay, once you produce those things, you have your impact, right? People start to value your opinion. People start to value how you think about things. Okay, and that's how you become a leader in your own field. Okay, because we provide unique insight for whatever you want to do. Okay.
All right, so let's actually for the first 3 chapters. Okay. Then we come to our midterm 2. This is actually exactly the summary sheet, equation sheet I summarized previously. Okay, let's put it here again so you can actually have a good reference point to check. Okay. So for midterm 2, the key idea is that pH calculation is actually the main thing, right? So I tell everybody that in order to actually do well for midterm 2, the most important ability is to identify what kind of solution that you have. Right? You can have strong acid, strong base, weak acid, base, and buffer. Okay. That's the number 1 things that you need to do. And I believe that our session is doing pretty well for midterm 2. Okay, so you should be able to handle that. Okay. So this table summarizes how you calculate the pH of different solution, right? Strong acid, weak acid, strong base, weak base, buffer. Okay, so it's not many to, I mean, if you're confident, you can still feel like, okay, I know this one already, right? I don't really have to memorize it. Okay, so these actually are things that you will need to actually know first. This is actually a part that gets students so confused, right? So chapter 15. Yeah. Chapter 15 is about the titration, right? Titration is actually a part that require you have the thinking that you have an original solution. Okay, it could be strong acid, strong base, weak acid, base, and buffer. Right. Then you add in your titrant, which can only be strong acid or strong base. Right. We have a concept that only weak acid with base, they can coexist on the buffer. Right. If today you have a solution, you're adding a strong acid. Okay. That strong acid will kill all other base inside your solution, regardless of strong or weak. Right. To calculate the pH of that solution, you actually find out the concentration of those species at equilibrium. Right. So that is actually a part that gets students confused. I think we're doing fine. Okay, everybody seems actually can understand. Okay, you cannot just use the value given in the question directly. You need to actually do the calculation. After all this and that concern, you want to find the survivor, right? Yeah. So it's a hunger game. Then you have to re-identify what is actually the remaining species, and starting from there, then get back to the chapter 14 and recalculate your pH. Okay, so here I summarize the solution that you're going to have, right? Like just going through, I use this one as example to refresh your memory. Okay, let's think about this. Then you have a strong acid as your analyte. Okay, then you start to add in the strong base to titrate it, right? So we always have 4 zones. Zone number 1 is actually before titration, right? So if you have strong acid, then that's what you're going to have in the zone number 1. Okay. Zone number 2 is actually before your equivalence point, right? That means actually you still have more analyte than your titrant. Therefore, you still have a strong acid solution. But when you hit zone 3, which is at equivalence point, right? All this strong acid will consumed by the strong base. all you have is just water, therefore it becomes neutral. And if you go beyond zone 3, which you enter zone 4, meaning you have more hydrate now. Therefore, you're going to have a strong base. Okay. If today you start with a weak acid, okay, zone 1 is a weak acid, no problem. Okay. Zone 2 is actually the interesting zone, right? Because right now, your weak acid is going to interact with your strong base to produce its conjugated base. Okay, so at equilibrium, all you have is actually weak acid and weak base. Then come to the buffer zone, right? Yeah. So once you have a buffer, then you actually equation by actually calculate the concentration or moles of your weak acid and weak base. Okay, that's how you get the pH of less specific solution. Okay. When you hit the equivalence point, all your weak acid will be consumed by your strong base and produce the weak base. Right, so to actually recalculate what is actually the weak base concentration, then get a pH after that. Okay, and after the equivalence point, all you to do is actually calculate the remaining strong base inside your solution for the pH. Okay, so those are the things that you have to practice yourself. Okay, can I actually imagine this process and understand what kind of solution that I have? Do I know how to calculate the concentration of strong base, strong acid, strong base, so gas with base concentration at equilibrium, right? If you can actually do that, then you are pretty much set. Okay. So another thing that this kind of just reminders, this again from the old note. Okay. So every time when we're trying to calculate the remaining acid or base, we're going to write some equation. Okay, so our training is that if you have strong acid, you have H plus, strong base, OH minus, weak acid, HA, weak base, A minus. Okay, so using these symbols to actually greatly simplify your questions. Okay, you can see the nature of the question more clearly. Okay, and then when you calculate the remaining one, make sure you use more, but not concentrations. Okay, you need to use more to find out the survivors. Okay, so if you can do that, then I think that you can easily determine the correct concentration of your titrated buffer. Okay, so let's go to chapter 15. Chapter 16 is simpler. Okay, I didn't even put anything here, right? The KSP, right? Again, the only thing that need to be careful is actually to know for the solubility, right? So once it dissociates, if it's not like one-to-one dissociation, the coefficient of that needs to be considered. Okay, so let's actually really quick summaries of the contents for this actually from chapter 12 all the way to chapter 16. Okay, so we just reviewed chapters 17 to 18, 16 to 18 last week. Okay, so on Thursday, okay, I will actually try to collect more questions, okay, from the beginning to now. Okay, so if you have a specific question you want me to go through, feel free to post it on the Q&A channel. Okay, then I can actually go through those things in person. Okay, but I will still prepare a bunch of questions. Okay, so that we can at least form some basic understanding of the things we're going to be testing for the final. Okay, so let's say for today, okay, if you haven't actually finished your midterm 3, good luck with your midterm 3.